Hi, this is lesson 1-3, measuring segments. It's a pretty easy lesson. There's just some notation that I have to explain to you. But basically a coordinate is just a real number that corresponds to a point. So on this little ruler here that I have as an example, we have A, and there's a capital A up here trying to show you the length of it. And the coordinate of B is right here, so the coordinate is just the real number that corresponds to a point, and I don't even have any real numbers here, but I'm just showing you what they would be for each of those coordinates. Now what we're going to do a lot is find the distance of a line, so I'm going to find the distance from A to B. The distance is the absolute value of the difference of the coordinates of the points. So it's the absolute value of the difference means to subtract, of the coordinates of the points. So again, I have the example, I have the coordinate A and B, so I want to find the length of AB, so I put those two capital letters together like that. And what I do is I take the coordinates of A and I subtract the coordinates of B, but the distance or length of something always has to be a positive number, so I'm just going to take the absolute value of that difference. So I'm going to take the coordinates of A, the coordinate of B, and subtract them, and then just make sure my answer is always positive by taking the absolute value. So it's the absolute value of the difference of the coordinates of the points. Now when we're doing our proofs, we're going to be able to use what's called the segment addition postulate. If 3 points, A, B, and C, are collinear, collinear means they form a line, so you see how we have A, B, and C right here forming a line, and B is between A and C, so I have B right in between A and C, then what I can do is I can add them. AB, the length of AB, the distance between A and B, plus BC, see how I'm adding BC here, the difference between B and C, that length, will equal AC, which is the whole thing. So all I'm doing is I'm taking two segments and I'm adding them, and that will equal the whole segment. So AB plus BC equals AC. And I'll do that in my proofs sometimes, so that is an important postulate. Okay, and the other important thing for today is something called congruent segments. Congruent segments are segments that have the same length. So if the length of AB is 1 inch and the length of CD is 1 inch, they have the same length, so I say that they're equal. The length of AB equals the length of CD. But that corresponds into saying that the segments are actually congruent to each other. So see how I have this little slash mark indicating that they're the same length? Okay, but then I say that they're congruent. Now when I'm using the congruent symbol, I have a little bar across it because I'm talking about line segment AB is congruent to line segment CD. So this is important right here. The measures are equal. When I'm talking about the measures, I don't have a line segment over AB and CD. The segments are congruent. So when I'm talking about the segments, I do have that little line segment above AB and CD, and I use the congruent symbol. So that's an important difference between equal and congruent. The measures are equal, they have the same length, and the segments are congruent. Now if I want to compare segment lengths, like I just want to see if AC and BD are congruent to each other, well, I have to find the length of AC, so find the length of AC. A is the point -2, and C is between 4 and 6, so C is 5. So you're going to subtract that, -2 minus 5, but you want to take the absolute value, you always want a positive number, and then find the length of BD. So B is between 2 and 4, D is 10. Okay, and then just find the length of AC and BD, and then you can tell me yes or no if they're congruent, or if you want to write a statement saying they're congruent or not congruent. Okay, and the very last thing for today is something called midpoint. Midpoint is a point that divides the segment into two congruent segments. So it's a point that divides the segment into two congruent segments. So on the little picture that I have here, B is the midpoint of AC. See how B is in the middle, and this on the left, AB, is congruent to BC. And I write that down. I don't think that's written on your paper, so you can add that. So AB is congruent to BC. B is called the midpoint. It's a point that divides the segment into two congruent segments. The line, however, L, okay, so L is a line, that's called the segment bisector. So the line is bisecting the segment, which basically means that it intersects at the midpoint. But B is an actual point that's in the middle, and L is the line that intersects at the midpoint. And that's it for today. See you in class tomorrow.